that they want you to graph. There's a lot of, other instructions there.
Mhm.
The very first thing that you might be asked to do is identify the parent function. And that is y equals x squared. Is that clear to you because of the square there?
Yeah, I think so.
Okay, the
The
next,
only thing about it is if there's like that square there, just rated as x squared.
if it's squared, it's it's x squared if you see a square.
All right.
Okay, so there are quite a number here. There are 1, 2, 3, 4 transformations. The order is very important here.
Mhm.
The first one is this +3.
+3, and that would actually be going 3 to the left.
Left, yeah, left 3 units.
Yeah, moves horizontally 3 units to the left.
Yes, that's very important. The 2 is the next one for me. You could make an argument that it's negative, but
Mhm.
the 2 is a vertical stretch.
Stretch, which is multiplying the y values by 2.
Right. So what you're doing actually over here on the right, which is really good, is you're actually like identifying what do you do. This one, you subtract 3x from x. It depends on how you want to write it. And that's multiply y by 2.
All right.
The negative is the next one. And
That
that's,
would make the graph flip, right?
yep, reflect or flip
Over the axis.
over x-axis. And that affects the y value. So you can say negate y.
And then I guess
And
we'd
that,
also have to move up vertically 5
yep,
units.
yep, up 5 units. And again, that affects y. Just a moment here, I'll be right back.
Yeah.
All right, Zach, so that affects the y again, y, +5
Mm-hmm.
kind of thing. So then the first thing you need to graph is the parent graph.
So that's 0, 0, 1, -1 and 1, +1 and 1, and then 2 and 4, and -2 and 4.
Right, and we're gonna reuse this table, so I'm gonna actually write it here. Because we're gonna reuse these values. I'll copy and paste them. It's -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4. I don't know if your instructor needs you to label the points.
I'm just gonna do it anyways.
You probably should. It needs to have a curve to it. It's not straight lines. It needs to have arrows at the end.
Is there any of them that would just be straight, or?
No, they're all kind of a little curve to them.
All right.
It's U shaped, and if you make a U, there's no straight lines.
Mm-hmm. So then, yeah, you just place them. Then you gotta just move it to the left by 3, flip it over the x-axis, then multiply all the numbers by 2.
Right. So my question to you is can we do that all at once, or does your instructor want to see it like one at a time?
It's like, I mean, most of the time we've been doing this, it's like she's just given us like 7 graphs and we can just fill it out on that.
I mean, it's very slow to do them one at a time, but like we could do that. We could do it for each transformation. What do you want to do?
Because I've already done this one, like this problem in specific, I think it's fine if we just do it all at once.
Okay, so notice the first one only affects x. So you're going to subtract 3 from each of these x values. And you don't have to start here. You can actually start at 2. 2 minus 3 is -1. 1 minus 3 is -2. 0 minus 3 is -3. You might even start seeing a pattern when you do this.
Wait, so we're subtracting 3?
Yes.
Again?
From x. So it's let me grab this some colors here. So to go from this to this, you subtract 3, -2 minus 3.
All right.
And then to go from like let's just say 2 to -1, you're also subtracting 3. It's 2 minus 3.
I'm just not sure like why we're doing that though.
Right here, because we're going left 3.
Show.
The first transformation is left 3 units.
Oh, okay. Sorry. I was just confused because like
Let-
what we do is we just do it on the graph.
Oh, I
I
would
thought-
recommend doing a table. I would not, and maybe that's different what you're seeing in class. Like I like to change the numbers and then go and graph it because
Yeah, that's
there's
the best way.
because you don't know whether you're going up, down, lots could be happening.
Okay, yeah, that makes sense now. I was just so confused for a moment there.
And that's why I write these here because for the next one here, for this, I'm gonna do it in blue here, to go from 4 to whatever we're gonna put over here, you have to first multiply by 2. So you take this value of 4 and you multiply it by 2.
By 2, and then you have to.
That's 8. Then you negate it. So it's -8. And then you add 5. So it ends up being -3.
Yeah.
And like that's why I asked, like, if you want to do a few in a row, but you can do this. It's not impossible here, because you're actually doing the same thing over and over again. Like you'll start seeing the pattern here of this. So like you take the next value 1, you multiply it by 2, that's 2, you negate it, that's -2, and then you add 5, that's +3, or just 3, I guess.
Yeah.
See if you can fill in the next couple here for me, please.
Wait, sorry. So you're multiplying by 2 and then you subtract 3.
No, you negate it. It's the ones in blue. The blue are the Y's. And you have to do them in this order. The subtract 3 we're done with. That was X only.
Sorry, I'm just a little bit lost right now.
Okay. Did you write down multiply Y by 2, negate Y plus 5?
Yeah.
Okay. Like when you vertical stretch something, that only affects Y. When you reflect or flip, that only affects Y. When you go up 5, that only affects Y. And I'm trying to give you the values. I know the way it sounds like what you've been doing is going to the graph, but it's the same steps. Like you have to take this point, like this point was 1, 1, right? And so now you're going to go left 3, which is here, is this -2. But then you got to do all this other stuff. You got to multiply it by 2, negate it, and then you got to add 5. And I'm asking you to do it in the table. I really think you'll find it's easier.
All right.
You try it for a problem or two. So like we're looking at this value of 0. This value of 0 is this point, right? 0, 0 is down here, but we've already transformed to X. Now we need to transform Y. So you multiply it by 2. 0 times 2 is
0.
Then you negate 0, which is
0.
And then you add 5.
Which is just 5.
Yes. Okay, and then we're going to do it for the next Y value.
1 times 1 is 1.
No, you're multiplying by 2.
Oh, 1 times 2 is 2.
Okay, negate it. -2.
-2 plus 5 is 3.
Yes.
Okay.
See if you can do the last one for me, please. So it's this value of 4 here.
+3.
So you multiply by 2, that's 8. Negate it, that's -8. And then add 5, which is negative.
-3.
Right. It's okay to like show work over here to the side, like it's 4 times 2, which is 8. Then you negate it, then you add 5 to get -3. Like that's maybe we should have been doing that all along, but that's what we're doing to get these new ordered pairs. So you
Okay.
graph these new ordered pairs. And let me grab, so let me just do it in a different color here so you can see in the chart. So -5, -3, that's down here. -4, 3 is here. -3, 5 is like up here. And then you have symmetry. So it's going to look like that. Oops. And then -1, -3. So it's going to look like this. You're transformed.
Mm-hmm. Okay. Here, I think I'd like to move on from that part. I have a question about the range.
Sure. So the range is always based on this min or max.
Yeah. So I understand that part. Like I understand like it's like the weird symbol y/y, weird r, I mean weird e, then r.
Yeah.
Then
So if
the part I
it's
don't understand is like why, like I don't understand when y is greater than or less than.
so it's right here. If the graph opens up, okay. If the graph opens up and that looks like that's like this.
Mm-hmm.
Okay, it's y element of the real numbers, comma y. I don't know how you're doing this. Less. Sorry. So this for when it opens up, it's greater than or equal to whatever the. It's really called h.
Mm-hmm.
It's whatever this. It's. I'm sorry. It's h comma k. There's two points here. There's the x value and the y value. That number goes there. So if it opens
Okay.
up,
So if it opens up and then if it goes down, the number
if
is
it's down, it's curly brace y element the real numbers comma y less than or equal to h also.
okay, so that's super easy.
Yes. The domain is always all real numbers.
Yeah, domain is easy and range is easy. All right. I had one other question. Okay, so I think I'd like a little bit of practice with number 2 on the same thing.
Okay. Number
then-
2, I don't see a number 2. I see a 10 and I see a 11. Oh, maybe there's a 2. There's a 2.
Oh,
One
okay.
third x, 1/3 x.
Yeah,
Yes.
I was just
Okay.
a little, I maybe just went like, maybe not to do the same exact problem since like I've already done it in class and know this one,
Okay.
but one with like a different number like that.
Sure.
It's
Yeah, I mean,
like,
there's not that many they can give you here. Like the options are, let's say f of x equals like 1/5 x.
yeah, like I think that would be perfect to practice with.
Okay, so let's do this in an order that I think is nice. Let's find f of 0 first.
All right. Oh, oops, put the X in the wrong part.
So that's 1/5 to the 0 power.
F 0. So then,
So anything to the 0 power is always
a whole
one.
number.
It's always
Oh,
one.
okay.
And then f of 1. So anything to the power of 1 is what you started with.
Okay. So it's the just exact same because that's what it is.
Yes. And then, but 1/5 to the power of 2, that's squaring. That's saying multiply it by itself. It's like saying multiply 1/5 times 1/5. Or if you remember your exponent rules from last year, you square the top and you square the bottom.
All right.
Okay, so
do you
see, oh, sorry, go ahead.
Is it's like I swear when I was doing that, we made it be like not fractions.
Well, I'm asking, we're gonna do the negatives now. And do you see a pattern? Like, do you see a pattern either going this direction or do you see a pattern going this direction?
I see a pattern going the first direction.
Going up. What is the pattern? Like, what's the math operation to go up this way?
It's increasing by 50% each time.
Okay, so
Or adding.
it's not adding, it's multiple. It's either multiplying or dividing. And that's what I'm, because it depends on the way you look at it, how we proceed. And it's It's either way is fine. Like if you're gonna go this way, you're actually multiplying by 5.
Uh-huh.
Okay. You like 125 times 5 is 1/5. 1/5 times 5 is 1.
Okay.
Is that what you see or not? Because if you see it going the other way,
I understand
like
that.
if you go this way, it's divided by 5. You go this way, you're dividing by 5.
Um, honestly, maybe just divided by 5 seems easier.
Okay, so what number divided by 5 gets you to 1?
5.
5. So without knowing, yeah,
Oh,
without
and
knowing how to do
25.
this, like you can actually write the answer down. Like we can talk about flipping inside and all that, but like there's a pattern here.
Uh-huh.
So let's move all this down just a tiny bit there. And what number do you divide by 5 to get 5?
25.
So would you believe that 1/5 to the -2 is 25?
Yes.
Okay.
So positives are fractions.
Well, it depends what's inside. And that's why
Mhm.
most people, so teachers start you out with the negative ones in the table, but you don't have to. You can start with 0, which is easy. 1
Mhm.
itself, 2 is kind of straightforward. Like to build a pattern, to build like, okay, I get it kind of thing.
Yeah. Okay.
Because if this number isn't a fraction, everything's kind of flipped. Okay, so let's try another one here, just like this in some ways, if that's okay.
Yeah.
But I'm gonna switch it up just slightly. Okay,
And
let's
then
say,
we actually scroll up just super quick for
sure,
it.
of course.
So then if we were to graph that, we'd look at it as like -1 and 5, -2 and
Yes,
5. Okay.
right. So it's way up here, and then it's, then it's coming down, and these aren't to scale, but it's,
Mhm.
it's really steep, and then it does that.
And then the asymptote, I can never pronounce that, would
Yeah,
be,
asymptote.
would I write that as 0 or 0, 0?
It's y = 0. It's a line.
Okay. All right, I'm good to go.
Okay, so this kind of related problem is like, what if I tell you f of x equals 3 to the x? Okay, and we're gonna pattern it again. So what is 3 to the 0?
0.
Anything to the 0 power is 1.
Oh my God. Okay, I need to get that down.
Yeah. Make sure you roll out of bed and you're like, okay, x to the 0 is 1. It's really important for math.
X to the 0 is 1.
There's this thing on social media. It's like where a guy can't sleep because he can't figure out what 0 to the 0 is, but you don't need to worry about that because x to the 0 is 1 every time.
All right.
Right. So then 3 to the power of 1 is
Would that
3.
be- All right.
So, and then let's do f to the 2. 3 squared is 9. What is the pattern? Either going, whichever way you want to go. You're multiplying by 3, right?
Yeah.
So this is where it's a little tougher. What number do you multiply by 3 to get 1?
Like 3.3333333.
So here's what you just said. 10/3 times 3 is 1, but it's actually 10. Did you mean this 0.333?
Yeah.
Okay, I'm sorry. Maybe I misheard. So 1/3 times 3, and that's why maybe it's better to go backwards. So you're dividing by 3.
Mhm. Yeah, I think
Divide.
that's better. Like I can see division better than
Okay.
multiplication.
So what's 1/3 divided by 3?
A ninth.
1/9. So these are f to the -1, f to the -2. Okay, and so on.
All right, man. Okay, this is like a whole new look at this thing.
It is, and it's better. It's easier. It's
Yeah,
more
this is really
straightforward.
nice.
I want to give you one after this. Maybe stare at it, write it down,
Mhm.
have you try one on your own here in a moment.
So then that would be -2 1/9, -1 1/3, 0 and 1, because 0 is always 1. X to the 0 is 1.
Yeah, you got to be careful because if it shifts left You're right, that changes things.
And then, okay, that's really not hard at all. Once you just get that down. I think I'd be ready to do one of those on my own.
Okay. All right, so you asked for it, you get it here. F of x equals 1/4 to the power of x. I want, and in no particular order, but I do want all of these when you're done.
All right.
You can do them however you want, but take a moment and see if you can get that by yourself.
Okay, I think I got it.
I'm gonna write down the correct answers here, and you can tell me if
For
that's what
0, I got 1. For 1, I got 4. For 2, I got 1/16. And then for -1, I got 4, and then -2, I got 16.
sounds good to me.
And then my question is on this one. I think I got the negatives or the fractions like mixed up. So for this one, the +1 and the +2 are the ones with fractions in them.
That's right. That's right. So like if we were to work through this together, I would have started here and said, like, what is anything to the 0 power? And you would say 1.
1.
Anything to the power of 1 is itself.
Oh,
So x to the 1
1/4.
is 1. X to the 0 is 1. I'm sorry, x to the 1 is x. X to the 0 is
Mhm.
1.
So then what if it was -1?
Well, so sure, but let's just make sure this is clear. 1/4 squared is 1/4 times 1/4.
1/16.
And then I would ask you, it's okay, Zach, like which way do you want to go? Do you want to go up, or do you want to go like which direction? Kind of like, pretend like we don't know these yet. So what's the
Mhm.
pattern? What do you see here?
It's looks like it's getting divided by 4.
If you
Or
go
multiplied.
this, we got it. So it's fine whichever way, but like I'm going to draw an arrow. So if you multiply by 4, that's this way.
Yeah.
Okay. So what is 1 times 4?
1 times 4 is 4.
4. And I would do
Right.
that. I would not try and focus on like flipping and all this stuff. Like you will
Mhm.
do that later in this course, or you've done that last year. I don't recall, but like keep it, there's this
And then
kiss,
plus.
keep it super
Then
simple
4.
is what I like. Super
Mhm.
simple because it's kind of kind. Um,
Yeah.
don't overcomplicate things that don't need to be overcomplicated. Look for the pattern with the nice ones and then apply it to the others.
Okay. Okay, yeah. So then wait, could you scroll up to the last one before this, please, real quick?
Yes, and I'm switching. I'm switching between whole
Yeah,
numbers.
okay, because I was gonna
Like,
say
and I'm going to switch again here. I want you to do one more of these, but
yeah,
like,
this time I'm gonna like look at it truly like this.
okay, good. All right, so let's do another one here. Let's do, and there are variations of this. Like, I got to be careful here, not like make you think like you've got it, because there's a few things the instructor could do
Yeah.
to make this unclear, but we'll try to avoid those. So take a minute or two, whatever you need, see if you can work this through, please.
All right. Okay, so I like have all of it except -2.
Okay, so let's go, we'll just go through this together. So 5 to the 0 is,
1,
and 5 to the 1 is itself.
5.
5 squared is 25. So
Oh, right. Okay. Never
so
mind. I just wrote it. I wrote it as 10 instead of 25. I don't know why I keep doing that. So then 25 divided by 5 divided by 5. Then 125. Okay, yeah, now I have the -2. So then you'd have 2 is 25, 1 is 5, 0 is 1, -1 is a fifth, and then -2 is 1/25.
yes.
Okay. Man, all right. I really need to like not write that as 10 again.
You know, you get the notes right at the end, take a look at it, you know, watch the video in, 1.5 speed, later on today or tomorrow, and, see if it makes sense. One of the things we haven't covered yet, and I do think we should, is let's say I give you a graph of something that you haven't quite seen before, like 3 to the minus x plus 1, because this could be a test question,
All right.
believe it or not. But what I want to focus on is this part right here. So if you're adding, and then let's just say over here it's y equals 4 to the minus x minus 3, or subtracting, whatever this is right here,
Mm-hmm.
this is your horizontal asymptote. So this one on the left, it's y equals 1, and this one on the right is y equals minus 3.
Mm-hmm.
And if that's not clear, I would like to graph those for you right now to see them,
Yeah, I think that's a good
so
idea.
that you can see that. So give me just a moment here. I'm going to switch sharing
Yeah, of
to
course.
Desmos here, and we'll take a look together. So the first one I said was y equals 3 to the minus x power. So notice if I draw a horizontal line here at y equals 0, do you see how the red is approaching the blue?
Uh-huh.
You see that? Now, if the problem I gave you, I said, oh yeah, it's +1 here. So do you see how that moved everything up +1? So
Yeah.
the horizontal asymptote is there at y equals 1. So whatever this number is to the right of the exponential, that's
Uh-huh.
your horizontal asymptote.
Okay.
Okay, so let's look at
Oh,
another.
shoot, yeah, that's an easier way to look at it. I always just do it and then I like look down one and it's just already there.
Yeah, let's do another one here. So let's say it's 4 to the minus x. Okay. The horizontal asymptote is again 0. The green, I can zoom in forever, and the green is always approaching the purple.
Yeah.
Okay. But then I changed it. I said, okay, what if I subtract 3 from it? So I got to zoom out. Okay. And if I make this, it's the whole thing, including the sign. If I make it -3, again, see that horizontal asymptote there? The
Mm-hmm.
green is approaching the purple there.
Yeah.
Is that okay?
Mm-hmm. That's clear.
All right. So if we go back to our notes, what I was trying to show you without kind of like making a new problem, if you're seeing my screen, is that like whatever this is, that's your horizontal asymptote.
Okay. Yeah, that makes sense.
Great. So that's like another, like, you got to know that, you got to remember that kind of thing. Okay. Where should we go from here?
Um, okay, I guess I mean back to the number 2, but the B part to it. Use transformations to graph the function gx equals 1/3 x plus 2. That's basically what you just showed me.
Did can we do a different one than this?
Yeah, I'd like to do different numbers just because I
Okay.
already did it.
Yeah. So let's do this instructor made a mistake here. Okay, so let me grab this part and then we'll do it together. Okay, so I'm going to give you a new thing here. We're going to go, okay, we're going to go f of x equals 2 to the x minus 5.
All right.
It's really similar to what you just saw, what you had there, but There's only one transformation. You know what? I'm sorry. We should not do that. Let's make this 1/2 to the power of x minus 5.
Okay.
Okay, so there are two transformations, but before we even do that, you need to know what the parent function is. And this one's a little bit harder. So the parent function is 2 to the x.
Okay.
And I don't really have a good way to explain that. It's the reciprocal of this.
So if it was like 16, it would just be 16 to the x.
See, yeah, kind of. You could actually make a case that that's something else, but
Oh,
yes, like generally, yes. This is
so
where,
what I'm doing now, that's how it's gonna be.
yeah, I mean, so, but then you might think, well, I haven't seen this before, and you're right, you haven't, because this can be rewritten another way that kind of shows you what it is. But when you graph, let me go down here. Actually, let me jump back to Desmos real quick, and I'll try to explain this that way. Graphing is just so much more powerful way of doing this. So here I'm gonna make two graphs: y equals 2 to the x. Okay, and let me go back here, and then the other one is going to be the reciprocal function of that, 1/2 to the power of x. Could you, in words, tell me what you see
It's like a reflection, like
over which axis?
the y-axis.
Yes, very good, very good. Okay, so if we go back to your problem, okay, because this 1/2 and 2 are reflections over the y-axis. So if you were to be looking at like something like 1/3 x and 3 to the x, they're reflections over the y-axis. So that's the first transformation, is reflection over the y-axis.
All right. So then,
You seem your body language, which I can't see, but like I would think
yeah.
you don't agree with that, or you still don't feel like, even though you just told me, you said, hey Matthew, it's reflected over the y-axis, you still don't like that.
I mean, it's like I think maybe I just need to continue the problem to like have it
Okay.
like fit in with the other like puzzle pieces, I guess.
Okay. So then the -5 is down 5 units.
hmm Yeah, I think it's like pretty like I understand it, but then it's just like I think if I just see the rest of it, then I'll get it.
Okay. So I don't want to do the rest of this until we graph it. So the
hmm
way I would tell you to graph it is I would tell you to say, okay, what does 2 to the x look like? And actually, I'm just going to do it down here because I don't have any. I want to make sure you have the room. What is the graph of 2 to the x? Okay, look like? And
One, oh, sorry, one, 2, and 4.
okay, so you're dividing by 2 each
Divide by
time.
2, dividing by 2.
Okay, so this new one, and this is why it's so important to get the transformations down. Like actually the emphasis should be on like, can you write the transformation down correctly every time? Because if you can do that, you can make the changes here. Both of these, I'm sorry, this first one affects the x values. So when you reflect over the y-axis, you change the sign of x. Like you negate x is what ends up happening. So -2 goes to 2, -1 goes to 1, 0, -1, -2.
All right.
Which now it's all backwards, but that's okay.
Like it makes sense. You gotta change that.
Yeah. Okay, and then you're going down 5 units. So you tap to each of these y values, you subtract.
So then,
Like do the easy ones first. 4 minus 5 is -1.
-1 minus 5 is -6.
No, it's the y values.
Oh shoot.
Yeah, you're done with the x. This is y subtract
-3,
-3,
-4,
right?
and then
This is where it gets hard. Like subtract 5, so it's -4.5 and then -4.75.
okay. So then that would leave you with the numbers for your graph. So 0, -4, -1, -3, -2, -1, and so on. So I should just look at,
Sorry, graph this
if
completely
it's
wrong.
like a fraction, I should just look at it as the bottom number is the whole number instead of it as a fraction.
You can, yeah, you can do that.
Because once it's like that, then I can move on with the problem. What's this one called? Is this the vertex?
Oh, we messed this up. I'm so sorry. I don't actually like this. Okay, can we just reset here?
Yeah, of course.
Okay. There's some other things going on here that are probably not as helpful. But like this is where it gets a little weird, and it would probably actually be better to put these new values into the original function. I'm sorry, this 1/2 x function.
Mhm.
So like when you have 1/2 x there, like 1/2 to the power of 0 is 1,
Uh-huh.
and 1/2 to the power of 1 is 1/2, and then 1/2 to the power of 2 is 1/4. What do you see the pattern here?
Oh yeah, because it's like just doing what we were before.
Yeah, but so what that makes this
It's
2 and
going,
that 4. Do you follow that?
yeah, it's getting multiplied by 2.
But now we need to subtract 5 from each of
Oh,
these.
so
So
then
when we subtract
-1,
5, you get -1. Subtract 5, you get
-2,
-3.
-4.
So
Uh,
it's not, we're not getting any different, but this might be a better way to do it. I don't know. So you're subtracting 5. Sorry, subtract 5, minus 4.75. So now we've got some points here: -2, 1, -1, -1, -3, 0, -4, and then 1 minus 4.5, 2 minus 4.75. So these are actually approaching something here. What is the horizontal asymptote of this?
um,
It's this number right there. It's always this. Yeah, so just like just like we talked about in the last problem, whatever this is adding or subtracting, that's the horizontal asymptote. So these are approaching it.
okay. That makes more sense for whatever reason.
Great.
Um, so I guess really that kind of leaves me with,
So a few more things here. Y-intercept. The Y-intercept is when x is 0.
that would be -4.
Yeah, y is -4. The domain is always all real numbers. The range, though, is kind of like the x squared. There's two possibilities for these.
Mhm.
So if your graph looks like either of the following, if it looks like this, or if it looks like this, your range is y element real numbers, comma, y greater than whatever this number is here, which is usually called k.
All
And
right.
then the other type of graph you might see is, well, what if it does this, or it looks like this?
Less than.
Yeah.
Okay, so it's like the same as the other.
Yep. But it's
Okay.
less. The other one was less, greater than or equal to, and less than or equal to. The issue here is that it approaches but never touches. That's why it's greater than or less than.
Okay, cool. All right, yeah, that makes sense to me now. I never really got that. I just kind of like base it if it was negative or positive, which is wrong.
Yeah. So these are good like note cards to have, or like if you're gonna review the notes, these are good things to look at again if you got time.
Yeah. Okay. I guess maybe like one other. Do you think you could open up the image of 11 just for
Yep.
yourself?
Yep. I see
Um,
11 there.
yeah, I think I sent an email with a picture.
I've got it. Do you want us to look at it together?
I think so. Like, I think I might just want to like explain the steps you take to see if like they're just correct.
All right, let's start out with
I
the
think I just
parent.
want a little bit of practice with that.
What's the parent function for this one?
Um, quadratic.
Yes, and how would you write it? Y equals or f of x equals?
Uh, F. So F. No.
F of x is fine. Y equals is fine, whichever one you
F
want.
of X equals.
This is what matters over here.
That's the part of him I'm making flashcards for. Like
So
MX.
there's only a couple options. X squared, absolute value of x, 2 to the x. These are kind of the only ones you have.
Mm-hmm.
So which one do you see here?
I guess 2 to the X.
These are different. One x squared is a variable to a number. This is a number to a variable.
Uh-huh.
So you have x to a number.
X to a number. And why is it? Oh shoot! I don't know what I was doing there.
It's a common thing to do. For some reason, I don't know how the brain
Yeah,
works.
now that I look
but
at that, I'm like, wait, what am I talking about?
it's the difference is it's variable to number.
Mhm.
That's x squared. And then it's not the same, but it looks the same if you're not paying attention very clear. Number to variable, that's 2 to x.
Mhm.
They're different, but they kind of, I mean, they got the same. It's like
Same as,
it's like calling something a walk side instead of a sidewalk. I mean, like they're not really the same,
uh-huh.
but that's what it is. So, okay, that's so now that we got that, and you got to know that there are transformations. There's 1, 2, 3, 4 transformations here. The first one is the -3. What does that correspond to?
It will horizontally move the graph to the right by 3 units.
So does that affect x or y?
That will affect both.
Just x. Just x. The transformations only ever affect one value.
Okay.
They either affect x or they affect y.
All right, that makes sense.
So this
And then,
only x, and you're going to add 3.
mhm.
The next one is this 1/2. What does the 1/2 do?
The 1/2 will make it stretch.
It's vertical though, so it's a shrink.
Right.
Yeah.
Shrink. So it'll vertically shrink by half. So
Yeah.
everything have to make half, right?
So y, you basically divide by 2.
Divide by 2.
Yeah.
And then if it's not a fraction, then you multiply by 2.
Right. Right. So the next one is this negative out in front.
So that negative in front makes the graph flip or reflect over the x-axis.
Okay, and that also only affects y. You end up
Mhm.
negating it.
And then for the final part, the 1, you will vertically move the graph up 1 unit.
Up 1 unit, and that also only affects
The
y. So y
Actually,
plus 1. So do you see how only the first one affects x, because left or right is the only thing that affects x in
yeah,
your
now that makes sense to me. I was thinking of it like more practically, where it's like every single number is technically moving.
Yeah, and that's where it doesn't like, and that's why this table. So let me just see if I can go down a little bit, not too far, not too far. Here's your original x squared, -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4. If you truly like believe this and you like get it and you're like, okay, I can do that, Matthew, like your transformations come from like this on the right here. You add like your x values, you just add 3 to each of them.
All right.
That's your new x and your new y. We're going to get separately.
So then you have to add 3 to the x, so then that would be +1, +2, +3, +4, +5, and then
Good.
you have to divide those by 2, which is
No. The y's now.
yeah,
You're
I
done.
meant that.
Yeah. So the y's you first divide by 2.
So then you have 2.
Okay. But then you have to negate it.
So -2.
and then you add 1 to it.
-1.
Right. So you had your 4, you divided it by 2, then you, so that made 2. Let me just write the result there. Sorry. That equals 2. Then you negated it. Then you added 1 to it to get -1. So for this one, you're going to divide it by 2,
which is then a half.
Then you negate it.
+1.
+1 gives you
1/2.
Okay. You go to this 0. 0 divided by 2 is
0.
And you
+1.
negate it, which is 0, so just 1. And then 1 divided by 2 is 1/2. You negate it, add 1.
1/2.
1/2. And then 4 divided by 2 is 2. Negate it, +1 is -1. Just want to make sure we get that all in on this last one.
Then you have.
Let me ask you one more question before we go. Does this open up or down? And it depends on this right there.
It is.
It's down when this is negative.
Oh, okay. I was like, wait, does it mean like side by side or up and down?
No. Okay. And then this is that K value for the range that I was talking about.
To go up.
Yeah, but in terms of the range here is Y, because it opens down less than or equal to 1.
Oh, right. Because okay, yeah. Is the 1 is greater than the Y because your graph's going down.
That's right. That's right. All right. Well, that does take us to the end of our lesson for today. I will send you the notes here shortly. And thanks for scheduling. I'll see you next time.
Yeah, see you, Matthew. Thanks.
Thank you. Bye now.